So just a basic overview of what we're going to be talking about, what the cloud is, why it's important. We're going to talk about how to set up a basic network within AWS. That encompasses how to launch an instance, different components of a VPC, security measures you should take when configuring your VPC, different AWS managed services that are frequently used within VPCs, and VPC best practices. We are also going to tackle security measures within AWS at an application layer, as well as AWS Serverless Services. A few of these we're going to cover: object storage, file storage, Lambda. We're also going to talk about different strategies where you can keep costs low. If you're very familiar with quite a few of these, you can probably take a look at one of our other presentations. This one's a little bit more of an introduction. However, there are likely still a couple of things you can learn. But if you haven't worked with AWS all that much and you're not familiar with how to set up a network or different services, then this is definitely the right place and we can get started. So on to the next slide. Just going to talk about what is the cloud. It is essentially composed of servers in data centers from all over the world. This led to the field of cloud computing, which is the on-demand delivery of IP resources over the internet with pay-as-you-go pricing instead of buying, owning, maintaining physical data centers and servers. You can now access technology services such as computing power, storage, and databases on an as-needed basis from a cloud provider such as AWS. One or two terms you may hear fairly often are public cloud versus the private cloud. So the private cloud hosting solution, which is also known as an internal cloud, it resides on the company's intranet or their internal network, and all their data is typically behind a firewall within their own data center. This can be a great option for companies who already have expensive data centers because they can use their current infrastructure, which again, they already have. And it's much easier for them because they already have all the resources. However, if they do need to, they are in charge of handling all of the updating, upgrading, managing, maintenance, everything for that cloud. And the primary differentiator between public and private cloud is that with public cloud, you're not responsible for any of the management of the infrastructure itself. Your data is stored in the provider's data center and they are responsible for handling that. We can go on to the next slide, which talks about why you should move to the cloud, the different benefits of the cloud. So one big thing is the ease of access and operation. Organizations have unlimited access to computing power and they can make changes and upgrades on the fly. You can get set up very easily without being a cloud expert, which is great. The scalability of on-demand resources. AWS instances allow you to scale up or down your computing resources according to your business needs. So you don't need to sit down and purchase individual instances or individual servers to try to predict what your usage would be like. If you experience a sudden raise in demand, you can easily launch more instances or upgrade the instance size so you have more computing power just on the fly. It's very quick, easy. And if there's a drop in traffic, you can also easily get rid of extra instances without a worry. Elasticity and flexibility of operations. So you're no longer required to predict computing resources for the next couple of years. AWS's utility-based metering system helps give your business the elasticity to align your infrastructure to whatever the needs are and the demand. The high-end security infrastructure, you have several tools at your disposal which are put into place to help you keep your environment secure and encrypted, just to keep all of your data safe. Major cut down on infrastructure, staff, and downtime costs because of all the previously mentioned reasons. Shifting your workload to AWS can alleviate some administrative work you'd otherwise be doing. For traditional business models, a major source of expenditure is the installation, configuration, maintenance of on-premise servers, but with AWS's pay-per-use, it helps eliminate many of those costs without locking you into any long-term contracts with services that you don't want. And we'll dive a little bit more into these as we go on. Now we're going to begin talking about how to set up a basic network within AWS. And one of the primary things you want to focus on is how to launch an EC2 instance. EC2 just stands for Elastic Compute Cloud. It's Amazon's name for a virtual machine. And we'll dive a little bit more into these as we go along with the presentation. This is just a more general overview. You need to select an image, so an AMI, to create that instance. You need to select the infrastructure resources for that instance, choose the network placement and addressing, so the VPC, which stands for Virtual Private Cloud, add storage, optional tagging if you want to keep your instances a little bit more organized, and you can apply a security group. Although these do seem very daunting, like there are quite a few things, you also do have defaults that Amazon has put in place for you. So if you're just getting started, there are default security groups, a default VPC, which can help you get started as you're learning how to work a little bit more with it. We can go on to the next slide, talk about AMI, so Amazon Machine Images, as I already mentioned. An AMI is a pre-configured template that you would use to launch an instance. AWS provides a set of publicly available AMIs that contain software configurations at no charge to use, and there are quite a few. As you can expect from many Amazon services, an AMI is compressed, encrypted, and secured, no matter which operating you use for that AMI. Customers can also create their own AMIs, which contain customized settings, installed applications, and configurations. This is very helpful because, for example, if you are currently using Cognos, you can have an image with Cognos pre-installed on that image. So that way, when you're trying to get an environment set up, you want it very quick, you can easily spin up multiple servers or multiple virtual machines from that one instance, and all you need from that one image. So you can launch virtual instances from that one same image, which already has Cognos pre-installed. So it just makes it much faster. You can get an entire environment set up much quicker. So a couple of examples of AMIs would be with Ubuntu. You can have Windows with a SQL server on, without, Oracle, Linux. You have a lot to select from. Furthermore, you also have different instance types that you can select from. These are very valuable because your different applications may require different optimization. If your application is focused more on compute power or memory, storage, you can select that family from the instance type. And that way, again, you don't need to buy a physical server with that specific optimization. If you start off with a compute optimized, you can also easily change it over time if you decide that you want it to be more memory focused as opposed to compute optimized. So you do have quite a few different selections. The other nice aspect of this is that if you do want to test something out, as I mentioned, going back to the example of Cognos, if you want to test out a new version of Cognos, you can very easily launch an instance with the latest version. You can try out the compute optimized family of instances. You can play around with it, see how you feel about it prior to actually deploying anything in your environment, in your production environment. So the instance types just give you a little bit more, a few more options in order to make sure that the virtual machines are more tailored to your specific application's needs. Along with instance type, you also need to select a storage. So EC2 instances come with instance store, which is temporary block level storage that is used. It is physically attached to the host and it consists of ephemeral storage. This means that the data persists only for the duration of the lifetime of its associated instance. So if you stop and then start that instance again later, that data will be lost. It is used primarily to store things such as swap files. Again, it's typically very small, very quick nonetheless. So many people opt for EBS, which is elastic block storage. It can be used as a primary storage for data that requires frequent and granular updates. This could be for a database or a file system. It is very durable, detachable, and there's also very low latency. You can launch an EBS volume with multi-AZ, so multiple availability zones. This means that AWS would replicate the data volume across multiple servers within that availability zone and other zones to help keep it reliable, durable. It is also secure. You can use encrypted EBS volumes, and Amazon would handle that encryption for you. As I mentioned, it is low latency, and this is just a very common storage option. It acts as a virtual hard drive, so you can also attach multiple hard drives to your instance, just like you would be able to attach multiple hard drives to your computer at home, if that's an easier way to think about it. And similar to instances, you also have different families or different types of block storage, which you can select depending on your application needs. So again, you can tailor it to your application to really get the most out of this service. All right, we're going to talk a little bit more about networking. So we learned how to launch an instance, or the different things you have to select when launching an instance. An instance goes within a VPC. A VPC is a virtual private cloud. It's important because it enables you to build a virtual network in the AWS cloud without requiring any hardware, VPNs, or physical data servers. VPCs act as a network isolation component that blocks traffic entering the VPC unless there is a defined network path. So it really just helps you organize all of your instances, and it helps you keep your virtual environment structured, organized. All instances go within a subnet, which is the little box that's around those blocks at the bottom. The orange blocks are the instances. And you can have subnets in different availability zones. And you can think of an availability zone just as a data center located in a different area. This is great if you want to keep your application highly available, just in case one availability zone does go down, although it is unlikely, it may happen. So having different subnets and different availability zones is a great tool to keep your application highly available. And the point of having a lot of organization for your environment and using a VPC, it's meant to allow you to spend less time managing the network, so you can focus a lot more on the actual application that's running within your VPC. All right, we're going to begin talking about basic security within the VPC. So you have security groups, which act as a virtual firewall to control inbound and outbound traffic for your instance. So again, this firewall is at an instance level. A little bit higher up above that is a network access control list, which is also known as a NACL. And this is also a virtual firewall, also has rules, and this is at a subnet level. So typically with security, the more layers you have, the more secure your application is, the more secure your instances are. So the more layers you can add on there, just the better, good, general best practices. You do have to select a security group in a NACL. However, as I mentioned a little bit earlier on, if you are unsure what to select, you also do have defaults, which allow more ports to be open. But in case you're just trying to play around with something, run some tests, that's a great option if you feel a little bit overwhelmed by different rules. You also do have routing tables, which they consist of different pathways to allow the resources within your VPC to communicate with each other, or with resources outside of that VPC as well. So if you don't have a path within that routing table, the traffic cannot access those instances, which again acts as another security measure because you only want to keep the necessary paths on the route table within the VPC. Also, in regards to routing tables, the way to make a subnet public is by including a route from that subnet to the internet gateway. So that is one way that you would make the subnet public. However, you only want to do this for your public-facing instances and not for your private instances or the location that you're storing your data. That's just general best practice. With VPCs, you can also enable VPC flow logs, which is just a way to detect and keep track of traffic that's flowing inside and outside of your VPC. And two other great things for security within your VPC are bastion hosts and endpoints, which we are going to talk about in just a second. On the next slide here, I'm just going over an overview of throwing the VPC diagram at you quite a few times, just because at first it can seem overwhelming, but the more you're exposed to it, the more familiar it looks, the easier it is to understand. So all the way at the bottom, you have your instances, again, the orange blocks. At that instance level, you have security groups within the subnet. Above that, you have the network access control list, and then you have your routing table. So again, just all these different layers of security, which can help your instances and the data on your instances stay much more secure. We can talk about bastion hosts. So bastion host serves as a jump box. It is a special purpose computer on a network specifically designed and configured to withstand attacks. So it has very tight security. It is used to manage access to an internal or a private network from an external network. So it allows traffic coming from the outside going into your VPC in a safe, secure manner. It is always located on a public subnet, and bastion hosts typically host a single application or a process, so for example, a proxy server, and you can connect to the bastion host using SSH, RDP, depending on what your instance is, but it just allows more secure access to your private instances. The next thing are endpoints. So endpoints are virtual devices. They are horizontally scaled, redundant, and highly available VPC components. You have internet and gateway endpoints. They allow you to connect your EC2 instances to certain AWS services without requiring public IP addresses. This is also very important because it also allows for this communication to happen without imposing availability risks or bandwidth constraints on your network traffic, which again leads to improved security. And it is free to use. Gateway endpoints and interface endpoints are also very, very cost effective and cheap. The important thing about endpoints is that it allows different resources to communicate with each other outside of your VPC without having to use the public internet. So the more frequently you use the internet to be able to allow your internal resources to communicate with resources outside of the VPC, the more you're exposing your data, and it's just not a great idea. It's not a best practice. So best practice is to use endpoints, and they are managed by AWS. They are a great tool. Going on to talk about managed services, here I have 3 different services that are listed there. These are just 3 of many that are offered by AWS. From a technical standpoint, services that are fully managed by AWS don't differ much from the ones that you would manage on your own. There's always an underlying server. You retain control over a service, but not over an operating system or the virtual instances underneath, which is quite handy because AWS relieves you of the administrative burden while you can still set up the services according to your needs. So you're not responsible for all of the patching, updating. AWS is, which, as I mentioned, allows you to focus a lot more on your application itself. And when you choose an AWS managed service, you don't need to worry about the redundancy or failover. It's all handled by Amazon. It also ensures that your resources are highly available depending on the service itself, and they handle everything behind the scenes, so it really makes things a lot easier. One of those managed services is a NAT gateway, very, very popular and commonly used. It stands for Network Address Translation. It allows instances and private subnets to access the internet. It is used for patching, updating software, downloading packages. A NAT gateway is very similar to a router in your home network. It gets a single public IP address, and it performs network address translation for any service that uses that NAT gateway. Just like with your router at home, it only routes traffic from the internet to the private server where the outbound request was initiated. So it doesn't allow any unsolicited inbound traffic to your private instances, which is very, very important for security. Prior to NAT gateways, typically NAT instances were used, which is just an EC2 instance that is configured to work in a similar way that a NAT gateway would. However, your network would be limited by the instance type and size that you would select. And if that instance went down, the resources within your VPC that were relying on that instance would no longer get access to the internet. So the NAT gateway was created to really help handle that. As I mentioned, because it is a managed service, you don't have to worry there's automatic failover for it. You can have instances in different availability zones access that same NAT gateway, so you no longer have to configure that instance yourself, handle all the security and everything again on your own, just to be able to give access, internet access to your private instances. So just taking one more look at a VPC again, all the way on the left, you have your Bastion host, which is the instance that's configured to withstand a lot of attacks. The security groups are the little red lines around it. The NAT gateway, those are within the public subnet, and then you have your private subnet with the different instances, security groups, NACLs, availability zones, routing tables. Again, just putting it all together in regards to the VPC, so you can get a better idea of what that architecture looks like. One more managed service that we're going to be talking about are elastic load balancers. The primary purpose for elastic load balancers are to serve as a single point of contact for clients. They distribute incoming traffic across multiple targets within multiple availability zones. There are 4 different types, but we are going to be talking about primarily just application load balancers. Those are the most intelligent and the most commonly used. The ALB, so application load balancer, it monitors the health of the registered targets. It also automatically scales in response to the traffic load. It makes routing decisions at an application layer, and it supports path-based routing. So you can really set those different rules for how you want the traffic from the application load balancer to be distributed among your different instances and your resources, which is very helpful. Because as we talked about security a little bit, you can also have your instances only allow one security group rule from the application load balancer. So again, less ports open, the more secure your environment is. One more managed service, RDS, Relational Database Service. They are very easy to set up. In the name, it's pretty self-explanatory. So you have compatible with several database engines. A few examples, MariaDB, Oracle, Microsoft SQL Server. They are very highly available. They're read replicas. You can launch them in multiple availability zones. And AWS would synchronously replicate the data to a standby instance in a different availability zone. So it does support automatic failover. It also takes automatic backups. All these things you would typically do with your own database and have your own team handle. RDS does automatically. Security and patching is already taken care of by AWS. You do have encryption at rest and in transit. And for those of you that are running Cognos, one question that does come up is if IBM provides the same level of support for Cognos using an RDS database as opposed to an on-premise, and the answer is yes. IBM supports the software, supports Cognos as the application itself and not necessarily the underlying infrastructure. So whether you're using an on-premise instance or an on-premise database, or you're shifting and using the database engine on top of RDS, then you would still receive the same level of support from IBM. However, if there was an issue with the underlying infrastructure, because RDS is a managed service, Amazon would be in charge of handling and making sure that the instance is up and running, which also means minimal downtime. Application will flow as smoothly using the database engine. So IBM does provide the same level of support. Just again, throwing the VPC your way one more time, you have your public subnet, 2 different private subnets, and best practice, always keep, as I already mentioned, your sensitive data within private subnets. So you see all the way on the right a RDS instance with the database in a private instance. And in this diagram, you also see a load balancer, which can divert traffic to the different instances in the different subnets. So this also just shows what a load balancer would look like within that environment. In even simpler terms, this is just a diagram of a 3-tier application. You can have multiple load balancers. One common practice is to use an application load balancer that is public facing, so that is what all the clients would access, and then to also use an application load balancer that is facing inward, so towards the internal resources. And within this diagram, you have a web tier, an application tier, and then you have all of your private data. One best practice for your application is to have your different resources constantly communicate using private IP addresses. You want to access the internet through the internet gateway as little as possible, because you really don't want to expose your resources, your instances, to the public internet. So using the endpoints, using all these different managed services, keeping all of your information, data secure and within the same VPC is really key to launching the best VPC, keeping everything secure, and having your application flow in the most secure way. So as we go on, we're going to be talking about security measures within AWS at an application layer. AWS takes up the shared responsibility model, and this means that the customer is responsible for things that are happening within the cloud, but AWS itself is responsible for handling the cloud itself, so security of the cloud. So this means that AWS is focused on infrastructure security, including computing, storage, database, and intrusion prevention networking services. AWS is also responsible for the security of software, hardware, and the physical facilities that host the AWS services. The customer is responsible for the secure usage of AWS services that are considered unmanaged. So that would include managing user base access, authentication methods, encryption of data, things of that sort. However, this, as I already mentioned, the responsibility shifts a little bit more if you're using managed services, because AWS handles a lot of the security and the encryption of the data within a cloud if it is within a managed service. So that is something that you can take as a load off of the team if you decide to use AWS managed services. Another very important tool is IAM, which stands for Identity Access Management. It is a centralized mechanism for creating and managing individual users and their permissions within the AWS account. You can create different groups, roles. There are different permissions that you can assign to different users. The best practice is to create either groups or roles and attach all of the permissions to those groups or roles. That way, you can just attach users within, or you can insert the users within those different groups. It makes it a lot easier than attaching several policies to each individual user, assuming a company can get pretty big and have quite a few users. IAM is very important because the careful management of access credentials is really the foundation of how you can secure a lot of your resources within the cloud. So you want to limit access. You can also set up multi-factor authentication just as an additional security measure, but an additional best practice is to give the least amount of privilege for each user in the group. So you don't want to give users that do not require or do not use it access to resources that their responsibilities do not include. That is just something to keep in mind. We're going to talk about some more common security measures. So we already talked about how AWS managed services handle encryption. They handle encryption at rest and in transit. AWS managed services also use KMS, which stands for the key management service. The customer doesn't even have to worry about these. Amazon will already use the keys to make API calls on their own. And in regards to prevention, you do have several tools. We're only going to be talking about a few of them. So everything on this slide, just keep in mind, these are just a few. Amazon has even more. So AWS Shield is a common tool used for DDoS attacks. If you're unfamiliar with DDoS attacks, DDoS stands for a distributed denial of service, which occurs when multiple systems flood the bandwidth or resources of a targeted system. So AWS resources automatically have AWS Shield standard protecting them from the most common network and transport layer DDoS attacks. However, there is also a more advanced version if you are much more concerned about your security. On to the next one, the web application firewall, so WAF. It gives you control over how traffic reaches your applications by enabling you to create security rules that control bot traffic. And they block common attack patterns such as SQL injection or cross-site scripting. The next one is Amazon Inspector, which automatically assesses application for exposure. It also checks for vulnerabilities and deviations from best practices. So after performing an assessment, you would receive a detailed list of security findings prioritized by level of security. So even if you're not necessarily as sure on how to secure different aspects, the inspector can be very helpful with that. In regards to detecting things in regards to security, you could use CloudTrail. That is definitely highly recommended. It enables auditing and monitoring of authorized and unauthorized activities within the AWS account. Another tool is GuardDuty, which is a threat detection service that continuously monitors for malicious activity and unauthorized behavior to protect your AWS account, workloads, and data that is stored within your resources. The most important thing about this is just that by leveraging Amazon's built-in tools and best practices for security, it will reduce the amount of work that your security team will have to perform, but it will strengthen the defense of your environment with tested and reliable mechanisms. We can move on further down the agenda. So the next thing we're going to be talking about are serverless services. A lot of people tend to be a little bit scared of serverless because it encompasses a lot of different things. As we see in this slide, you have databases, gateways, security, a lot of services. Serverless just essentially means that you are not responsible or you don't have access to the underlying infrastructure for the different services. They enable you to build more agile applications. You can respond to changes faster and to innovate. You get charged based on their computation, and you do not have to reserve and pay for a fixed amount of bandwidth or the number of servers. One fascinating feature about serverless services is that they are auto-scaling and all the infrastructure tasks are handled by AWS. So we're going to begin talking about the first one, which is Amazon S3, which stands for Simple Storage Service. It is an object storage service, not a file system. It provides access to reliable and inexpensive data storage infrastructure. It is very scalable, virtually infinite. There's no limit on the amount of data that you can upload and store within S3. It is very reliable, designed for 99.9. There are 11 nines after the decimal point of durability. Amazon is very proud about that. And AWS automatically stores copies of the data across a minimum of 3 availability zones just to provide fault tolerance. As I mentioned, very, very highly available, and S3 is very commonly used for static hosting and system backups, websites, cloud native applications, things of that sort. However, S3 is also really the backbone of the majority of data lakes. So S3 is very important here in case your company is thinking about a potential data lake. S3 is the largest and the most performant object storage service for structured and unstructured data, and the storage service of choice to build a data lake. You can also enforce different access policies and manage objects at scale, as well as audit activities across the S3 data lake. So S3 is really something to keep in mind if you are looking at a data lake in the future. We're going to talk about a different type of storage, shared file storage. So Amazon has different file systems. You have EFS, Elastic File System, and you also have FSX. FSX is for Windows. These are simple serverless elastic file systems which let you share data without provisioning or managing storage. The whole point of elastic file systems, they grow and they shrink automatically as you add and remove files. You pay for only the storage space that you're actually using. There is no minimum fee. File systems can grow to petabyte scale, and they replicate across multiple availability zones. So really, they're very powerful. You can store as much data as you would like if you are looking to use shared file storage. And these are just an additional benefit of a serverless service. I'm going to talk about one more serverless service, which is Lambda. Lambda is very, very popular. It is Amazon's serverless compute service, and it allows you to run code without provisioning or managing servers. You can run code for any type of application backend services. All you have to do is just upload the code or the container image with nothing else. So it's very easy. It also automatically scales, just like the other serverless services. It scales depending on how much you feed into it. So just as a small example, in order to better understand one way that you could utilize Lambda, if you have, let's imagine your CPU is running beyond its specified limits and you're seeing either more or fewer activities than what you were expecting, CloudWatch, which is a tool that just monitors utilization, we'll talk a little bit about that later on. CloudWatch can trigger a Lambda function for you to notify your teams through email, or it can directly terminate underperforming resources. So if you do set an alarm, you can set an event to trigger Lambda to then elicit a response, get rid of the resources that have very low utilization, keep your costs low. Lambda can be used for a multitude of things, and that's just one of them. You can go further on down to the agenda. So we're going to talk about a different way to also keep costs low within AWS. So some things we've already talked about. Use AWS managed services. Really helps keeping overhead costs low. They handle all of the underlying infrastructure, failover, redundancy, everything. You really can't lose by using AWS managed services. You can also take advantage of serverless services. You're not paying for the underlying infrastructure. It's very helpful, and they're very intelligent. You can scale. You don't need to buy you don't need to purchase very large virtual machines or different things. As much as you feed into the serverless services, they will expand, and you only pay for what you're using. You definitely take advantage of those. The other thing is you can always start small and scale up as your business requires it. So even if you're just launching EC2 instances, you can always start with smaller instances, and as your business requires either larger instances or more, you can very easily upgrade that same instance without launching a new one if you want to keep using that same one, or you can deploy multiple instances from the same AMI. So you can really grow very quickly without committing to a very large number of instances or a very large environment. Another option to keep costs low is you can schedule your instances to be on and off during different hours. So if you are not a global company and your traffic is very, very low outside of business hours, you can schedule those instances to turn off, so you are not paying for the time that those instances are stopped. When those instances start back up, as you remember with the EBS volumes, that data will still persist. You only pay for the instances while they are actively running. So if they are stopped, you do not get charged. If your company can allow for it, then you can turn the instances off outside of business hours, cut costs in that way as well. I'm going to go a little bit further down, talking about different, we're not going to talk about all of these. There are quite a few options, but EC2 purchases. The automatic or the natural instance you get is on demand. That's just the default that you would get unless you specifically go for reserved instances. With on-demand instances, you pay for the compute capacity by the second, no commitments. You have full control over its life cycle. You can decide when to start, finish, stop, reboot, anything with the instance. You're in charge of that, and you only pay for it while it's actively running. If it's stopped, you don't pay, as I mentioned. You can also purchase reserved instances, which is essentially just a billing discount that's applied to the use of on-demand instances. This does require more of a commitment 1 to 3 years. So if you're at a point where you can predict a little bit more of your traffic load or how much usage you require, then reserved instances are a great option, which can save you roughly 50% of EC2 utilization. So you can utilization costs. So that's definitely a great option. There are also savings plans, which are just a little bit more flexible than reserved instances. But again, these assume that you are a little bit more familiar with what your traffic load looks like. If you're unaware, you can just stick to on-demand instances. And once you do have a better idea, you can switch over to reserved instances. So you really do cut costs a lot more that way. Some additional tools that you also have: CloudWatch, as I mentioned, touched lightly on a little bit earlier. It provides you with data and actionable insights to monitor your applications, respond to system-wide performance changes, optimize resource utilization, and get a unified view of operational health. It allows you to create custom reports that analyze cost and usage. You can also set different alarms, such as billing alarms, and you can determine what happens when you do cross those billing alarms. We mentioned the example with Lambda. You also have Cost Explorer, which is an easy-to-use interface that lets you visualize, understand, and manage your AWS costs and usage. AWS Budgets is a relatively new feature, I believe came out earlier this year, and it allows you to set custom budgets to track your costs and your usage from the simplest to the most complex use cases. It integrates with Cost Explorer, which is pretty neat, and you can configure specific actions to respond to cost and usage status in your accounts. So if the cost or the usage exceeds a certain threshold, actions can be executed automatically to reduce unintentional spending. AWS Trusted Advisor is a service which just draws upon best practices and inspects your AWS environment, making recommendations by saving money, improving system performance, and closing security gaps. Primary purpose of all of this is for you to understand that you also have many tools at your disposal which can help you really keep track of utilization, determine what you can get rid of, what you can keep, and how to save money along the way. We can go on to the next slide, which are just takeaways that we've learned throughout. So you should be a lot more familiar with how to set up a VPC, the different requirements of launching an instance, how to set up different security groups and ACLs, all the different layers of security. So overall, you should be a lot more aware that building a secure and organized VPC is really the foundation of shifting to the cloud and having that organization. AWS has many managed services that are secure, highly available, reliable, and highly scalable. You can definitely leverage those, use those to your benefit. Many AWS tools at your disposal to keep your application secure and cost efficient. We already talked about quite a few different tools that can help assess either security issues or ways where you can be saving money. AWS offers you the speed and the agility of developing and launching applications much faster. If you use AMIs, which have your pre-configured application already installed, or different things that you already need, it's very easy to get an environment set up, get some servers spinning up, everything working very, very quickly, as opposed to it taking months in a traditional on-premise solution. The other thing is there are no long-term commitments or upfront capital that is required to begin launching your environment. You can sign up for 1 to 3 year contracts for the instances if you are aware of what your load looks like and you'd like to save additional money. However, you do not have to pay upfront very large sums of money. You're only paying for what you're using, which is great for saving and really making the most out of all the resources that are at your fingertips with AWS.